Hey guys, hope you're having a good day. I wanted to make a quick video on a question that kept popping up during some of the Zoom calls, and that is Einthoven's triangle. Uh, so this is something that we can work on together. So why don't you grab a pen or pencil and a piece of paper, and we can draw some stuff out together. Now, what Einthoven's triangle is it takes the limbs leads and it kind of shows us what vectors that we're looking at when we use those leads to look at the heart. And this will eventually translate into cardiac access. You may have seen something like this in your book, this kind of wagon wheel looking thing that has some degrees and has our leads. And what this is we can use this to figure out our cardiac access. And this kind of shows us how the leads are looking at the heart. But this is something that we can cover in another class on how to use this. Right now we're just going to talk about Einthoven's triangle and basically build one of these. So there's a couple rules that we need to have when we talk about Einthoven's triangle in order to build our little cardiac access wheel. Rule number one, which is something you're probably familiar with, is that if I'm looking at a lead and I have a complex that is positive, that means that that electrical conduction is heading towards that lead that I'm looking at, or towards my eyeball. If we're looking at a lead, we can say the same lead, and I have a complex or a wave that is negative, that means that the electrical conduction is heading away from the lead that I'm looking at. And if I have one that kind of has an up and down, or what we call biphasic, what that means is that I'm looking at that electrical conduction from a perpendicular angle. Rule number two is a little complicated to wrap our heads around, but it's very important, and that is all electrical conduction will look the same if we look at it from a parallel lead. So if we move our eyeball down or up, as long as we stay parallel, that complex will look the same. All right. So let's get our patient, and we'll add some leads to them. All right, so we have our left arm, our left leg, our right leg, and our right arm. So what Einthoven's triangle is, it's going to look at the connection between our right arm and our left arm, our left arm, and our left leg, and our right arm with our left leg. Our right leg lead we can kind of forget about. It's a ground, and really it's used to kind of filter out some of the background noise that our bodies make. So back to our triangle here. As you can see, we kind of have this right triangle. But if we actually look at Einthoven's triangle and using some fancy math that we don't really need to know for this lecture, what we end up getting is, instead of a right triangle, an isosceles triangle. So that's going to look something more like this. Click these out. We're going to get something that looks more like this. So this would be our right arm, this would be our left arm, and that left leg would actually end up being more center. Okay? Let's get rid of our patient here and our leads. So this leaves us with our Einthoven's triangle. Now, if we place the heart here, we can kind of see that this makes us kind of look around the heart. And that makes it a little difficult. But that will bring us to that rule 2. So for now, let's think about what these leads are labeled as, or what these sides of our triangle are labeled as. So this top piece here, that's going to be lead 1. And if I was looking over here and I had a waveform that was heading this way, it would be positive. So we can kind of think of our eyeball being over here at the left arm lead. The next one is this right arm to left leg, and that's going to be lead 2. So if I had my eyeball down here and I had a waveform heading this way, it would be positive. Our last one is going to be lead 3, which is going to run from our left arm to our left leg, and our eyeball will be down here looking that way. And if I have a waveform that's heading down like this, that is positive. That would be lead 3. Let's clear some of this out. So again, lead 1, lead 2, lead 3. Now, as I said, this kind of bounces around the heart. We don't really seem like we're actually hitting anything. But if we remember rule 2, that everything that's parallel is the same, we can move these angles in towards the center of the heart, right about there. So if we get rid of our triangle, we can move these together and it will look something like that. Go back again. So this top piece will move in this way, this will move in here, and this will move in here. And that's when we get this. Let's clear some of this out. So again, lead 1, lead 2, and lead 3. And as a side note, as you can see here, if we look at lead 2, we can kind of see that our SA node would be here. Our AV node, bundle of His, junctional area would be here. And we have our left ventricle here. And this is the normal conductional pathway. So if we took an average of all the electrical conduction of a normal heartbeat, it would flow in this direction. And that's why we tend to look at lead 2. It gives us kind of that best picture. Now, what about the augmented leads? Let's kind of clear this up a little bit. If we go back to our triangle, and we remember that we have our left arm, our right arm, and our left leg. And we remember that our numbered leads were like so. Now, the number leads are called bipolar leads because they use 2 leads to get information. Our augmented leads are unipolar. They only use 1. But to make things easier, I like to think about it that the heart is the other lead when it comes to the augmented leads. So what we get is if we kind of put an imaginary lead in the middle of our heart, and we draw lines out to the corners, this is actually the view of our augmented leads. So let's clear this up a little bit. So what we get is something like this. Now, I think labeling these is fairly easy because we just kind of think about the side of the patient that it looks at. So the one that goes over here looks to the left side of the patient, so that would be AVL. One over here looks to the right side of the patient, that is AVR. And the one at the bottom looks at the foot, right? So AVF. And again, we would move all of our numbered limb leads in, and that's going to end up giving us something that looks a little more like this. So if we were to label these again, I always like to start out at this straight line here as lead 1. Anything heading this direction would be positive if we were looking at lead 1. The next one I usually like to do is lead 2, because we know that lead 2 is the one we like to look at, and that should be running from the SA node straight through to the ventricles. Kind of fill in the blank with lead 3, and then we hit our corners. Left side of the patient, AVL, right side of the patient, AVR, and the foot of the patient, AVF. And that's Einthoven's triangle and how it connects to starting to talk about axis deviation. I hope this kind of cleared up some stuff. We will probably use a little bit of this in my next video when I talk about how I like to do rhythm recognition. Thanks.